The first part of 11.7 is the fundamental principle of counting. And so we're going to look at a couple of examples to figure out what the fundamental principle of counting is. So the first example starts with Pete's. And Pete's is a restaurant where you can get 2 meals, a hamburger meal or a torta meal, and you can get 3 drinks, water, Coke, or lemonade. And so our job right now is we're going to list out all the possible meal combinations you can get if you get 1 drink and 1 main course. So one way you can do this is to list out, we have hamburger, tortas, and then the drink options, water, Coke, lemonade. And we can connect each course or each meal to each drink. So we could have hamburger with water. Let's do that in blue. Hamburger with water, hamburger with Coke, and hamburger with lemonade. And then we could have torta with water, torta with Coke, and a torta with lemonade. And so when we list all of these out, hamburger with water, hamburger with Coke, hamburger with lemonade, torta with water, torta with Coke, torta with lemonade, there are 6 meal combinations when we add those all up or count them all up. Okay, so let's look at another example. Same idea, we have Mamma Mia's. At Mamma Mia's, you can get 4 drinks. We have soda, iced tea, water, which I abbreviated H2O, and wine. And there are 3 main courses. Pasta Primavera, I'm going to erase all of those. Pasta Primavera, linguine and clam sauce, and spaghetti carbonara. So we're going to take each entree with each drink. So start with the drinks. So the first drink we're going to start with is soda. So we have soda with Pasta Primavera, soda with linguine and clam sauce, and soda with the spaghetti. Then we have the iced tea with each of those. So that gives us 3 more possibilities. Then we have the water with each of those, which gives us 3 more possibilities. And then we have the wine, which gives us 3 more possibilities. So when we list them all out, we have soda with Pasta Primavera, and soda with linguine and clam sauce, and soda with spaghetti, and iced tea with Pasta Primavera. And we can list all of these out. But when we do, we get that there are a total of 12 meal combinations with the drink and the main course. So looking at this and maybe using some inductive reasoning, in our first example with Pete's, we had 2 meal choices and 3 drink choices, and we got that there were 6 meal combinations. And then here with Mamma Mia's, we had 4 drink options and 3 main course options, and we ended up with 12 total possibilities. So, what could you have done with these numbers to get this? And does that work the same here? What could I do with these numbers to get this? So I'm going to let you think for about 5 seconds. See if you can figure out the pattern. If you want to pause and look back and forth, you can. But hopefully you're coming up with the idea where if you have P ways of doing one thing and Q ways of doing another thing, then there are P times Q total ways to do both things. So those are all considered. P times Q is the number of possible outcomes that you can get from the experiment, okay, or from the situation. So, looking back, on this one, we had P is 4, Q is 3. We had a total of 12 different possible outcomes, okay? 4 times 3 is 12. Here, our P was 2, our Q was 3, and we ended up having 2 times 3 outcomes. And so we don't actually have to list out all the possible outcomes, but this is the fundamental principle of counting, okay, or the fundamental counting principle. So again, it states that if there are P ways to do one thing and Q ways to do another thing, then there are P times Q ways to do both things. So that means P times Q gives us the number of all the possible outcomes of a situation. So it's the number of possible outcomes. Okay, so thinking about that, this can actually be expanded beyond when you just have two options. Because what if you had an appetizer, like 2 options for an appetizer, 4 options for a main course, and 2 options for a dessert? You could continue the same pattern. You would do 2 times 4 times 2 to find out all the possibilities that you could get for that meal. Okay? Let's look at an example. So, a restaurant offers 4 drink options, 3 appetizers, 8 main courses, and 2 desserts. If you get one of each to complete your meal, 1 drink, 1 appetizer, 1 main course, and 1 dessert for your meal, how many different meal combinations are there? So for this kind of problem, all we do is we take the number of options for each part of the meal and we just multiply them. 4 times 3 times 8 times 2. Multiplying that out, we get that there are 192 possible meal outcomes or possible meal combinations. Possible. So, hopefully this doesn't seem too complex. Note that when we're dealing with this, I would not be asking you to write out all 192 possibilities. So you have to read the questions very carefully. Sometimes the question might ask you to type out or write out all the options, all the possibilities, all the outcomes. But sometimes it's just asking you how many there are. And so make sure you read carefully so that you don't try and start listing out all the combinations, because if you do and there's 192, you're going to be there for a long time. And I want to do that to you, I promise. In the next example, we're looking at how many ways there are, how many highways there are to get from one city to the next. So from city A to city B, there are 2 highways. From city B to city C, there are 4 highways. And from city C to city D, there are 5 highways. So the question is, how many different routes are there from city A to city D? So if we have 2 options of how we get to B, and then we have 4 options of how we get from B to C, and then we have 5 options or 5 highway options from how we get from C to D, we just take 2 times 4 times 5, which equals 40 possible routes or routes, depending on how you say it. Let's think of the next example. We have a car. You can order a new car with the choice of 5 possible new colors. You can get it with or without automatic transmission. You can get it with or without air conditioning. I mean, we live in Texas, so I would never purchase a car without air conditioning unless I really had to. But with or without is an option, with or without power windows, and with or without a CD player. So if you think about this, the with or without for each of those, that's 2 options, right? You can either have yes, auto transmission, or no auto transmission. So for each of these, we have 2 options or 2 possibilities. And so we have how many total options or how many different ways can a new car be ordered? Well, that's going to be 5 times 2 times 2 times 2 times 2. Which gives us 80 different ways for this car to be ordered. Please be mindful that when you start seeing examples that have like different combinations of letters and numbers, your answer is going to be very big. And if you think about it, the next example, which you're going to do on your own, but it's talking about the number of license plates in the state of Texas. And if you got an answer that was like, how many possible license plate numbers could there be, and you got like 20, we know that that's not a good answer, because Clearly, we need way more than 20 license plates for all the cars, for all the people who live in the state of Texas. Let's look at one more example. Let's say we were taking a 5-question multiple choice test where each problem has 4 choices. So I'm going to draw a line for each question. There are 5 total questions. There are 4 answer choices for each question. To find out how many possible ways you could answer the questions, you would do 4 times 4 times 4 times 4 times 4. And if you notice, though, that repeated multiplication is the same thing as saying 4 to the 5th, which is a lot easier to put into your scientific calculator than it is to keep track of how many 4s you multiplied together. And sometimes they get a lot bigger. So you want to make sure you're not, that you're using exponents when you have repeated multiplication. And this concludes this first video for 11.7. The second video for 11.7 is going to go over permutations. So make sure you watch that one as well. Thank you.